Okay, this lesson is going to be on rational exponents, and rational means fraction, so fractional exponents. And what you have to know is that when you have a variable or whatever to a fractional exponent, the top is a power and the bottom is a root. And so this could be written a couple of different ways. You could write it as a root where it's a b root of x to the a power, or you could write it as the b root of x all to the a power. Those are the same thing, and it just depends on the situation you're in as to which one that you need. Sometimes one is easier than the other. So here's our examples. First, you just need to be able to transfer forms. 1/2 power would be a 2 root, which we call a square root, and we don't generally write the 2 in the little crook. So this we would just write as the square root of x, and the 1 is the power, and again we don't generally rewrite 1 as a power, so this would be just the square root of x. X to the 3/5 is one where we could write in either one of those forms I just mentioned. I could write the 5th root, because the 5 is on the bottom, of x cubed, or I could write it as the 5th root of x all cubed. Whichever one, that is considered radical form. Now, when you get something like this, x to the 2.5, you're like, that's not a fraction, that's a decimal. But it can be written as a fraction, because 2.5 is 2.5, or 5/2. You want to go with a top-heavy fraction when you convert it from a decimal to a fraction, and then you'll realize that's the square root of x to the 5th. So square root of x to the 5th, and I'm just going to write it like this for right now. I could write it the other way as well. And then our fourth example, I have a negative, and you have to remember what a negative power means. That means it moves to the bottom. So before I write it in radical form, I'm going to move that part to the bottom of the fraction. Then I'm going to write in radical form. It just now happens to be on the bottom. So it's a cube root, and the power is a 4. So cube root of y to the 4th. Okay, another type of problem is going backwards, writing in exponential form from what we just did. So if we think about this one, start by writing my variable, and then I think about the fraction. It's going to have a 3 on the bottom because that's the root, and then there's no power showing, so it's understood 1. So this will be x to the 1/3. Example 6, again, x is our variable. It's a cube root, so you'd have a 3 on the bottom. The 2 is the power, so that will go on top. 2/3. Now 7 I have because it has 8 and y inside. You need to put it in parentheses, or apply the fraction to both pieces. But I'm going to put it in parentheses just because I think that's probably the easiest way. The power of the 8 and the power of the y is an understood 1, so this would be a 1/5. Okay, and then example 8, this one's slightly different. The 8 is not underneath the square root, it's out front, so it just stays out front, and you only worry about the y. So you do y to the power, and this time the power on top is a 3, and that only applies to the y again, and this is a square root, and again we don't really write the 2 here, you have to know that it's a 2. So this would be y to the 3/2 power. Now, the next set of examples, the directions are evaluate, and anytime it says evaluate, that means get a number answer. So get a number answer. That might be something that you need to know, because there's other times when we evaluate things. We evaluate function notation and things like that. Anytime they say that, we're looking for a numeric answer. So here we have all of these two fractional powers. I'm going to put them in radical form first and then evaluate that. So 1/3 power means cube root. So I have the cube root of 27, and the cube root of 27 is 3. If you need to review that, go back and watch the video on radicals. Alright, number 10. This negative is not in the power, so that does not mean move it to the bottom. That means that's inside of the root. It's a negative number. So I'm going to rewrite this as the fifth root of negative 32. And now I'm going to make the decision. Should I put the 3 inside or on the outside? And if I put the 3 inside, I need to cube first because we work things from the inside out. And negative 32 cubed is going to be a huge number. So I'm going to put it on the outside and do that second. And that's a smart move because 32 is a perfect fifth. And so the fifth root of negative 32 is negative 2. And that's a whole lot easier to cube than it is to take the fifth root of some huge number. So negative 2 cubed would be negative 2 times negative 2 times negative 2, which is negative 8. Now 11 has the negative in the exponent, so this is different than 10. Okay, it's in the exponent, which means I need to move it to the bottom first. So 25 to the 1/2 power on the bottom. And the 1/2 power means square root. And again, once you move it, even though my writing's a little funky, the negative is gone because you've moved it to the bottom and done that part. So this is the square root of 25 when I change it to radical form. And then this is a case where we just deal with the positive situation of that square root. So I'm just going to say that's 1/5. And then example 12 is another one of those decimals. I'm going to change it first. So that'll be 3.5 changed to a decimal. So 3.5 is 7/2 as a top-heavy fraction. And again, this is a negative in the exponent. And a negative in the exponent says move it to the bottom. So that's 1/4 to the 7/2. And I'm going to write that then as a radical. And I need to make that same decision that I made in 10 when I do my square root, because that 2 on the bottom is a square root. Is it easier to take the square root of 4 and then do that to the 7th? Or is it easier to do 4 to the 7th power and take the square root of that? And again, 4 to the 7th power is going to be huge. So I'm going to do that one outside. I'm going to write it this way instead. Because I know that the square root of 4 is 2. And I can do 2 to the 7th a whole lot easier than 4 to the 7th. So that would be 128. Alright, let's move on to the last set of problems. And this is combining all of your exponent rules with your fractions. Because the plain exponent rules that we did in the last video, they still apply when the exponents are fractions. So the directions here are simplify, and so we want to get it in the simplest form possible. And I'm just going to leave these answers in exponential form. If you need them in radical form, you can turn them into radical form because you've learned how to do that in our previous examples. So according to our rules, if we are multiplying two variables that are the same, we can add the exponents. So this is x to the 2/3 plus 4/9. Since I'm adding fractions, I have to get a common denominator, and in this case that would be 9. And the second fraction didn't change, so I'm going to leave that 4. The first one I had to multiply the bottom by 3, so I need to multiply the top by 3 and get 6. So I have 6/9 and 4/9. That would be 10/9. And again, I'm just going to leave it in exponential form, but you could put it in radical form if you needed to. Alright, for number 14, I have x to the 3/4 and x to the 7/8. So this is a situation where we subtract. So I'm going to do 3/4 minus 7/8. And again, when I'm subtracting fractions, I need a common denominator. In this case, that would be an 8. The second fraction again stays the same. I had to multiply the bottom of the first one by 2 to get 8, so I need to multiply the top by 2. 3 times 2 is 6. So 6/8 minus 7/8 would be x to the negative 1/8, which means since I got a negative power, I need to move it to the bottom of the fraction. So that's 1/x to the 1/8, or again, I could write it in radical form, but I'm just not going to right now. Okay, last two examples. 15 has a whole bunch of stuff to the 1/4 power. So it applies to everything. So I like to put that to everything first and see what happens. So it's 81 to the 1/4. When you have power to a power, you multiply. So 16 times 1/4 is 4. The bottom I have 16 to the 1/4 power. And then the 2 times 1/4 would be 1/2. That looks like a 9. Let me erase and fix. Okay. Now I can work on these numbers. So the 81 to the 1/4 power means the 4th root of 81. And that y to the 4th is still fine. And then I have the 4th root of 16 and the x to the 1/2. I can't combine the y and the x, so I'm really not worried about these powers. But I can take the 4th root of 81, and that would be 3. If you need to do a 4th root in your calculator, if you'll hit 4 and then your math button, you should be able to scroll down and see an x root that you can use. If you need help with that, call me over. But so I get 3x to the 4th on top. And then the 4th root of 16 is 2. And I'm just going to bring that x to the 1/2 over. So that's simplified down. Okay, last example here. I want to first move this y with the negative exponent because any negative exponent needs to move. So I'm going to keep everything else where it is, but I'm going to move that to the bottom. And then I'm going to go figure out what to do with these powers. Since the x's are on top of each other, I am subtracting. So the 2 minus the 3/4. And the y's are on the bottom, so I'm going to do y and add those. 1/2 plus 1/3. Those are together. So then I'm going to come down here. I have to get common denominators, and the 2 is over an understood 1. So the common denominator is 4. And the second one didn't change. I had to multiply the 1 by 4. I need to multiply 2 by 4. On the bottom, this is the first time in these examples I have to get an actual common denominator that's not one that's already there. So between 2 and 3, that common denominator would be 6. I had to multiply 2 times 3 to get that, so I need to multiply 1 times 3. And then I had to multiply 3 times 2, so I need to multiply 1 times 2. And on top, I'm going to get 8/4 minus 3/4, so that's 5/4. On the bottom, I have y to the 3/6 plus 2/6 is 5/6. And there's nothing to move because nothing came out negative, and my x's and y's can't be combined. So that is the end of that. That concludes this lesson. If you have questions, please raise your hand and ask.